In this video, I'll review condensed formulas and functional groups of organic compounds with nitrogen. I'll introduce you to the following functional groups: amine, amide, imine, nitrile, and nitro. I strongly recommend reviewing the common bonding patterns of carbon, oxygen, hydrogen, and nitrogen, which you can find here and in the description. Let's get started. Let's convert this to a Lewis structure. There's the CH3 group at the end, and this is bonded to a methylene group. This carbon is then bonded to the next atom in the chain, so here's a nitrogen. In this example, the nitrogen is bonded to a hydrogen, and then bonded to the CH3 group at the end. We'll complete the octet by adding that lone pair on the nitrogen. So notice the nitrogen is not bonded to a carbonyl group. In this case, the nitrogen is bonded to two R groups and a hydrogen. Again, for nitrogens, the hydrogen can be considered an R group. And so when the nitrogen is bonded to three R groups, we'll call this an amine functional group. Just to sum up here, these are all amine functional groups. The nitrogen could be bonded to three R groups, or two R groups and a hydrogen, or one R group and two hydrogens, and they would all be considered amine functional groups. As a reminder, R is some carbon atom or some carbon chain. Let's convert this condensed formula into a Lewis structure. So we'll start with the CH3 group. And this carbon is then bonded to the next carbon in the chain. And then you notice that this carbon is then bonded to oxygen. Now be careful here, we've seen this before. This carbon does not have any hydrogen on it. And so if we continue the chain and bond to this oxygen, well, this carbon would then only have two bonds and not satisfy the octet rule. So when you see this common pattern, this CO with no hydrogen on there, this is a classic example of the carbonyl functional group. Now, the carbonyl functional group, as I've told my students and you've heard in earlier videos, is always part of some bigger functional group. So let's finish the structure and then we can name it. So the next atom in the chain here is nitrogen. This nitrogen is bonded to a hydrogen. Hydrogens cannot be in the middle of a chain, so I'll draw the hydrogen branching off here. And then this nitrogen continues on and is bonded to this carbon. So let's look at this nitrogen. The common bonding pattern for neutral nitrogen is three bonds and a lone pair. So we can continue on here, satisfy the octet rule for this carbon, and then finish the chain with this CH3 group. So back to the carbonyl functional group. The carbonyl functional group is always part of some bigger functional group. So right here, we have a carbonyl bonded to an R group. Remember, R is just some carbon atom. It could be a single carbon or some carbon chain. So I'll call this R or R prime. And on the other side of the carbonyl, we have the nitrogen. And the nitrogen is bonded to a hydrogen and some other R group. I'll call this R double prime. And so this common bonding pattern right here is called the amide functional group. It's important to note for nitrogens that this hydrogen is counted as an R group. So it's a hydrogen here, but this could very well be another R group. I'll call this R triple prime. Now these R groups right here could be hydrogens, the ones that are bonded to the nitrogen, and those will still be part of this amide functional group. Let's take a look at another nitrogen functional group. We see the nitrogen right here. Let's draw the Lewis structure and see what the bonding looks like here. In parentheses, to start a condensed formula, we see the CH3 groups twice. When we start a condensed formula with a group in parentheses, that means that this group is bonded to that first carbon right after the parentheses. So in this case, I'll start with this carbon. And around this carbon, I'll draw those CH3 groups. I'll go ahead and draw them like this. Give myself some space here. So we see carbon with the two bonds and then bonded to the next atom, which is a nitrogen. And then we see, continuing the chain, the nitrogen is bonded to this CH3 group. So we clearly see something's going on right here. The common bonding pattern for neutral carbon is 4 bonds and no lone pairs. This carbon only has 3 bonds. This nitrogen is neutral. The common bonding pattern should be 3 bonds and a lone pair. I'll draw in the lone pair here. And so you can see that nitrogen is missing a bond. We've seen this with some other functional groups. In this case, we can fix this by adding that extra bond. So now there's a double bond between carbon and nitrogen. This carbon-nitrogen double bond with nitrogen bonded to some other group, we can circle that, and this is called the imine functional group. Here's another compound that contains a nitrogen. Interestingly, you notice right away, there's no hydrogens on here. So let's go ahead and draw this Lewis structure. We've seen these before. When you have a parenthesis at the beginning of a condensed formula, it means that these groups, now there's 2 CH3 groups, they're bonded to the next carbon atom. So this carbon atom right here, I'll go ahead and draw it. And on this carbon atom, I'll draw the 2 CH3 groups. And it's bonded to a hydrogen atom. We'll continue the chain with this methylene group, or CH2. And then we'll continue the chain with this carbon atom. So far all the carbons satisfy the octet rule. Let's take a look at this carbon. It has no hydrogen on it. We can say that it is bonded to that next nitrogen atom. And notice that that's it. So for this example, we have to go to the bonding patterns. For neutral carbon, we expect 4 bonds and no lone pairs. For neutral nitrogen, we expect 3 bonds and a lone pair. So how can we fix this? A triple bond between the carbon and the nitrogen. This bonding pattern right here is called a cyano group, but also called a nitrile functional group. Let's take a look at this condensed formula, and you'll notice there's a nitrogen group here. It's written in an interesting way, NO2 in parentheses. Let's draw the Lewis structure and let's identify this functional group, this nitrogen that's bonded to these two oxygens, and something interesting happens here. So we'll start with the CH2 at the end, this methylene group, CH2. But interesting, the CH2 group is bonded to this carbon, which is bonded to this hydrogen. I'll draw the hydrogen here. And we'll continue the chain, and you'll notice there's another carbon bonded to one hydrogen. And before we get to the NO2 group, let's understand what's going on here. We've seen this in previous videos. The common bonding pattern for neutral carbon is to have 4 bonds and no lone pairs. In this case, each one of these carbons has only 3 bonds, and if you're looking at the condensed formula, we're already moving on to later in the chain. So of course we'll fix this by adding another bond. So this double bond right here, we can call this the alkene functional group. Now let's continue here. Whenever you see a group in parentheses, that means that this group is bonded to the previous carbon in the chain. So rather than continuing the chain, I'll draw this NO2 group. Now this is interesting. This is something that organic chemistry students just have to know. This NO2 group is called the nitro functional group, or the nitro group. So whenever you see an NO2, the way we write it is we have the carbon bonded directly to the nitrogen, and those 2 oxygens are bonded to the nitrogen as well. So I'll draw it this way, but one of those oxygens will draw with a double bond, and the other will draw with the single bond. Again, this is just the way that we write the nitro functional group. Let's add the lone pairs to satisfy the octet rule. So this oxygen has 2 bonds, we'll give it 2 lone pairs. This is a neutral oxygen. Interestingly, to satisfy the octet rule here, we'll have to add 3 lone pairs to the oxygen. Now this is where we do need to understand the bonding patterns of these elements. I have other videos on formal charge, and I'll refer you to those. I'll leave a link in the description. When we see an oxygen with 1 bond and 3 lone pairs, the formal charge is negative, a -1. Also, the common bonding pattern for nitrogen, as we've seen in this video, is 3 bonds and 1 lone pair for neutral nitrogen. Well, you can see here this nitrogen has 4 bonds and no lone pairs. It's still satisfying the octet rule, but it doesn't have that bonding pattern of neutral nitrogen. That's because this nitrogen is not neutral, and the formal charge for nitrogen with 4 bonds and no lone pairs is a +1. So interesting, while some of the atoms in this molecule do have a formal charge, the net charge actually cancels out, +1 and -1. But this whole section right here is what we'll call the nitro functional group. Let's go ahead and finish the Lewis structure. And there it is. So this whole thing right here, we can call the nitro group.